time for questions, but we can do this a little bit more informally. If you have questions as I'm talking, feel free, especially if they're more sort of clarifying type questions. So overall, my research focuses broadly on the relationship between mathematics teaching and mathematics learning in preschool through 12th grade mathematics. And in particular, I focus on teaching and learning with and for those students who are historically and systematically marginalized in mathematics. So that in particular would be girls and students of color, usually black and brown students. So with this particular focus, my work could be summarized as focusing on equitable mathematics teaching and learning. And I'll talk a little bit more about what I mean by that term in a moment. So my research trajectory has evolved so far along two lines. The first line has really focused more on how teachers develop equitable mathematics teaching practices. And I'll go into some more detail about what I mean by equitable teaching. So these are just a few examples of the various directions that has taken me. So one is thinking about how elementary perspective teachers adapt existing curriculum materials to be more inclusive of all students. One is thinking about, in a secondary math classroom, supporting group work with English language learners. And then another is thinking about, in a secondary classroom, bridging algebra and literacy with a social justice focus. And this is a piece that was written collaboratively with a teacher who was doing this work. So more broadly, I'm going to talk about what I mean by equitable mathematics teaching. And so here I shift the language a little bit to talk about, instead of equitable, equity-minded. And that's intentional because we know that with these teaching efforts, we often have equity goals, right? But we don't always know for sure whether the students experience that teaching as more equitable or whether or not the outcomes will be more equitable. So when we think about equity-minded mathematics teaching, we could start with sort of a foundation of standards-based instruction. So building off of principles to standards that the National Council of Teachers of Mathematics developed in 1989, and then again redeveloping in 2000 up to the Common Core standards and practices, and really with that approach to mathematics, focusing on sense-making and reasoning, problem-solving, and doing mathematics within context. So these are a couple of well-known texts across grade levels that sort of bring in that standards-based problem-solving and sense-making approach. And so research has shown that many of those efforts to make mathematics teaching more equitable have been effective in raising students' achievement, particularly for those students who are historically marginalized in mathematics, and so giving more students access to the dominant mathematics curriculum. But Rochelle Gutierrez pointed out that these aren't the only dimensions of equity that are important when we're thinking about students' experiences in mathematics. And so she proposed these other two dimensions of equity-minded mathematics teaching, calling those identity and power. So really thinking about the way that students come to see themselves as learners and doers of mathematics, and whether or not they have to give up some other part of themselves to be successful in mathematics or not, right? And then that also relates to this idea of power, right? So who has power in mathematics, right? Who has a space in mathematics, who has a voice, right? And so questioning some of those things, and also thinking about the way that mathematics itself can be used as a tool for power. So my work really focuses on these two dimensions of equity in thinking about mathematics teaching and learning. So with this focus on identity and power, it's oftentimes harder to sort of pinpoint whether or not the teaching that we think is equitable actually has an equitable outcome for students' identity and power, right, in the classroom. And so that led me to my second line of research, which was to ask how students experience these equity-minded teaching efforts. right? So when teachers are trying to make mathematics classrooms a space that is more inclusive of girls, or more inclusive of students of color, or more inclusive of emergent bilinguals, do students actually experience those efforts as being more inclusive, right? And so these are a couple of pieces that have started to come out along the second line of research. There's a piece coming out in May in JRME where I did a meta-synthesis of teaching math for social justice across pre-K through 12. And then this is a piece again with some teachers in Flint thinking about bringing in issues around the Flint water crisis with first and second graders, right? And to help them see themselves in the mathematics that they were doing there. So those are just a couple of examples of where that work has taken me, and this was what my dissertation work primarily focused on. So for the talk today, or for the study today that I'm going to share more about, that's going to continue to be what I focus on here. And more specifically, I'm going to talk to you about this research question. So how does equity-minded instruction support more equitable student engagement and mathematics identity development? So participation and engagement in mathematics, and also supporting students to see themselves as capable and learners and doers of mathematics without having to sacrifice other parts of who they are. So related to this question, I'm going to talk about a specific classroom that I was in for a year to investigate this particular question. And this is really, the study that I'm going to talk to you about today is really going to focus on sort of the nature of the way that students were engaged in mathematics through this particular equity-minded instructional approach that the teacher is using, which I'll talk more about as well. So the context for the research was an urban high school, so a small city in the Midwestern United States that is racially and ethnically diverse. There's actually a very large refugee population there, so at that school there were over 40 different languages that were spoken, and this classroom represented some of that linguistic diversity, but quite more representational of the racial and ethnic diversity across the school. It was also a newly founded magnet program, which was an open enrollment program within the public school that had a STEM focus. Right? So the high school sort of broke into two programs, the STEM focused program, or the high school that was there sort of revamped their older magnet focus, which was on the performing arts. So there were sort of two magnet options. So I was in the STEM focused magnet program, and across content areas, teachers were using project-based learning in this particular magnet program. So the idea there is that rather than teaching in units, right, where you would do like a circles unit, and then you would do, I don't know, like quadrilaterals or something like that, right, you teach, you investigate authentic real-world problems that bring in all of the required content, right, in more interdisciplinary ways. And so this particular group of students was part of the newly founded magnet program beginning in their 8th grade year. And they took 8th grade algebra combined with co-taught with earth science. So they called it earth math, right? And it was co-taught by the math teacher, who was actually part of this study also, and a science teacher as well. And then in 9th grade, they decided that having two high-stakes content areas together meant that they were often competing for time and they didn't always fit very well together, so they separated out geometry into a standalone block. And then biology and health and PE were integrated and co-taught instead. And then they had English and speech were co-taught, so they had some other co-taught courses. But then in year 3, of the newly founded magnet program, they decided to try integrating again math and science because they felt that Algebra 2 fit well with chemistry and physics. So it was Algebra 2 and chemistry for half a year, and then Algebra 2 and physics for half of a year. So the time that I was at the school, I was there for a full academic year during the 2nd year of the magnet program in the standalone geometry course. And the teacher that was working with this particular course is Miss Stone, so all names are pseudonyms. And she's a white female teacher who was in her 4th year of teaching at the time. She'd been at this school her whole teaching career, and she and I had a long-standing collaboration around issues of equity in mathematics teaching and learning. And so now I'm going to share a little bit more detail about her specific pedagogical approach and how the pedagogy that she was bringing in addressed different dimensions of equity. So one of the first pedagogical approaches that she was bringing into this project-based context is complex instruction. So complex instruction is a specific approach to collaborative learning. It's not specific to mathematics education, and it was developed out of Stanford beginning in the 1980s by educational sociologists and has been researched since then. It's been taken up in K-12 mathematics since the 90s, right? So people have written and researched quite a bit about this particular approach. So one thing that makes this an equity-minded approach is that there are specific strategies to ensure that students have access to the mathematics while they're working in small groups, and to sort of address some of the status issues that can cause inequities in small group work. Right? So students know who the smart students are. Right? So the common complaint about group work is that one student does all the work, right? And actually that's kind of smart, because if you give students a page of problems to do, they're going to give it to the student who can do them the fastest and correctly. Right? So there are some strategies within complex instruction to disrupt some of that, to sort of help students see different ways of being smart in mathematics and giving students different ways to contribute. So across the body of research in mathematics education on complex instruction, researchers have shown that access to doing mathematics in small group work, so not just giving everything to the smart student, but giving everyone access to actually participate and engage, is key to increasing mathematics achievement. Okay, so this is what a lot of the research has sort of shown how that works in practice. And then the research has also pointed to ways that complex instruction can address identity and power as well. So complex instruction strategies promote recognizing mathematical abilities that are traditionally not seen as important in the mathematics classroom. And so this really sets the stage for students who are typically marginalized in mathematics to see themselves as competent, right? So to develop identities as people who can do and learn mathematics. And so that helps to shift some of the power dynamics in the classroom so that all students have a voice in mathematics. And because it's collaborative learning, shifting that voice also away from the teacher, more towards the students. So the focus here on identity and power really tends to focus primarily on students' mathematics identities and pays little attention to some of their other identities, like their racial or their gendered identities. And also, when we're thinking about power, is really focusing on power and participation within the classroom itself, right? It doesn't really address other factors that the students experience outside of the classroom that might impact how they engage with mathematics. So those are a couple of ways in which complex instruction doesn't fully address all the goals that a teacher might have for equity-minded instruction. So Ms. Stone is also bringing in critical mathematical inquiry. So this has lots of different names. Some people call it critical mathematics, some people call it teaching math for social justice. I think those are the two most common that you hear. But I'm calling it critical mathematical inquiry, with the idea that the mathematics itself is more inquiry-based, right? And that the critical nature of the problems is more driven from the student's interest and things that the students want to inquire about. So critical mathematical inquiry, or math for social justice, is really thinking about translating ideas of critical pedagogy specifically to mathematics education. So again, ideas that have been around in education since the 1960s, 1970s, right, and have been developed across content areas and researched since then. People started picking up these ideas in mathematics education in the 1980s, more so outside the US and in higher education contexts. And so it's really been in the early 2000s that we've started to think about what this looks like in a K-12 setting. So I define, for the purposes of this study, critical mathematical inquiry to be students critically interrogating causes and remedies to social injustices through powerful forms of mathematical reasoning and inquiry that build on their knowledge of mathematics and their knowledge of the community, right? And so this is really a nice fit with the focus on project-based learning as well. So a little bit about some of the research on critical mathematical inquiry and what that tells us about how it emphasizes these different dimensions of equity. So in contrast to complex instruction, the equity focused within critical mathematical inquiry is really more on traditionally marginalized students developing more positive mathematical identities by coming to see mathematics as something that's important to their lives, right? And something that's also compatible with who they are as whole people, right? So with their racial, gendered, and other personal identities. Similarly, the focus on power is more thinking about power outside of the classroom and the way that mathematics can be used as a tool for social transformation, developing students' critical consciousness, right, and also shifting who is using mathematics, right? So rather than just being consumers of mathematics, reading about tables and graphs in the newspaper and taking that as fact, really starting to be critical of that and being producers of mathematics as well. So you can see there the gaps that sort of fills in with complex instruction, right? So more focus on personal identity development rather than mathematics identity development, and more focus on power outside of the classroom. The research on achievement and access in regards to critical mathematical inquiry is somewhat mixed. And so there are some studies that show that teachers are able to integrate the dominant mathematics curriculum, right? So the required one that teachers are required to teach for the classroom. But the research also suggests that oftentimes the work of doing authentic social justice inquiry is quite messy. So it really usually involves mathematics that's beyond students' grade level, right? And the complex, the social justice issues are also complex, right? So oftentimes in response, teachers will revert to more direct instruction with the mathematics or focusing on more procedural mathematics rather than sense-making and reasoning. And so we're not quite sure what the impact of that might be in the long term because most of these are single case studies, right, of teachers who are trying to bring this into their classroom. So with a little bit more information now about the teaching that was going on in this particular context, I wanted to just revisit the research question. And so what I'm really focusing on is how students are negotiating Ms. Stone's use of both critical mathematical inquiry and complex instruction. Right, so bringing these two things together, do the students experience that as a space that's more equitable and inclusive of who they are? And really, what is the nature, right, of mathematical inquiry when it's both collaborative and critical? So those are the things that I'm going to focus on as I talk a little bit about the findings. But before we get there, just a little bit of an overview about the projects that I'm going to focus on. So across the school year, students did 9 projects. And so for this study, I focused on 2. But I'm going to talk a little bit about 3 because the third one was related. So just to give you sort of some context for what the students were engaged with. So the teacher decided that she really wanted the students to focus on the social justice topic and the social justice issues around food deserts. So she defined food desert based on the USDA definition, which for an urban area means that there's not access to quality, affordable, or fresh food within a mile, right, from an area.
Sorry, everywhere in Denton's a food desert.
Yeah, I know. So for an urban area, I think for a rural area, I think it's 20 miles.
Okay. That's better.
Yeah, so the definition is different, right, depending on the area that you're in. So in this particular context, right, using the relevant definition, and so the teacher introduced this topic in different ways at 3 times across the school year. So we'll talk about that as Project 1, Project 2, and Project 3. You can sort of see how those were paced across the year. So one very early in the year, this is the Midwest, so they start school in September, not in August. So this is like really their first big project. And then again in January, which was technically still first semester, and then at the end of the school year. So the school year there ends around mid-June. Okay, so this was really their last big project. So I'm going to give you a little bit of information about what was involved in each of these projects. So because the school has a STEM focus, I'm going to talk a little bit about how the teacher integrated some of the STEM disciplinary pieces into each project as well. So the question that was really driving the first project was, do I live in a food desert? And this project was designed as sort of a mini project that was supposed to help students understand the distance formula and the midpoint formulas as part of a larger project that integrated more exploration of lines and angles. And so through this project, the teacher used dynamic geometry software. Specifically in this classroom, they used GeoGebra. So you can see a little bit here, right? The mathematical focus is on the distance formula, and then using dynamic software, right, to find the distance, and then also finding the midpoint as a possible place that you might put a grocery store. And students drawing on knowledge of the community to say whether or not that's a place that would make sense to put a grocery store. In the second project, the question that was really driving was, what other ways can we think about a place to put a grocery store in the community? And with this, it was focused more broadly on the city as a whole, not just the immediate neighborhood around students' houses. Okay? So they actually went onto the USDA website and found areas that were classified as food deserts, right, in the city, and then they used centers of triangles to think about where you might place a grocery store to maximally alleviate food deserts across the city. Right? And so that was really the mathematical focus, with centers of triangles, so things like orthocenter, things like that. And technology was integrated. The students did research on the USDA website, on the internet more broadly. They used GeoGebra, and then they had to create a presentation about their findings. They were also learning about nutrition and cell biology in their biohealth class, but the teachers weren't collaborating. So it just sort of happened that they were doing these things at the same time. In the third project, the driving force behind this project was that the students would propose to build a community garden at the school. And so this was a project in which the teachers actually collaborated across courses. So in their biohealth class, they were intentionally learning about photosynthesis and plant biology, to think about what should we plant, what is shade tolerant, what needs full sun, right? And so they were actually making decisions about which plants to propose to put in their garden based on what they were learning in their science class. And then in their English language arts class, they were writing an actual proposal for funding for the community garden to the school improvement committee. In the math class, they were bringing in, focusing on scale and three-dimensional geometry to actually build a three-dimensional model of the space as well as a blueprint for the garden. And so they were designing, there was more engineering design principles that were brought into this particular project because they were building the garden for an actual space at the school, and they were using technology in various ways. So they were doing research about prices of lumber, which plants to put there, that sort of thing. They had the option of using GeoGebra if they so chose. Some of the students chose to do a 3D printed model for their garden as well. So technology came in a few different ways there. So this was quite a robust project that students worked on for almost 2 months. So this one isn't quite part of what I'm going to talk about today. This was a study in and of itself, right, this particular project, but I wanted you to sort of know where students went with this. So I'm going to focus today on these first 2 projects, the sort of mini project about do I live in a food desert, and then using centers of triangles to propose a location for a grocery store. So across all of these projects, I observed in the classroom collecting video, field notes, and various artifacts of students' work, and then I did individual interviews with select students, and then focus group interviews with students as well. So the students that you're going to hear about today are Rosie, Jane, Blake, Dante, and George. So as they come up, I'll talk a little bit more about each one of them. Rosie is a Korean-American girl who is perceived to have the highest math status in the class. So I recognize that math identities and math status can change from moment to moment, right, depending on how students interact and perform in mathematics. But in general, students have a broader idea of like, you're good at math or you're not, right? So when I say status, that's sort of what I'm talking about, is how students position themselves and each other as good at math or not. Okay? So Rosie was the best girl at math. Jane is a black girl who was perceived as sort of medium-low status in mathematics. Blake is a white boy who was perceived to have a medium-high status and was also Rosie's boyfriend. And Dante is a black boy who had a perceived low status in math, and George, a white boy with a perceived low status in math, and these 2 were pretty close friends. Okay, so you'll see some group interactions that come out along friendships as well. So in order to analyze the data, I used a theoretical framing called figured worlds. So this is a framework that's been borrowed from anthropology by educational researchers as a way to understand how people make sense of experience. Right? So when I want to understand how do students experience the instruction that they're engaging with, then figured worlds is a way to make sense of experience. And it allows me to think about how people use various social, cultural, and political worlds as frames of reference, right, to figure out the significance of people or actions or values, right, or particular outcomes. Right? So I'll give some examples to make this a little bit more concrete. But the important thing that comes out of this idea of figured worlds is this construct called a storyline. So sometimes people would equate this to the idea of a norm, right? So these sort of taken for granted ways that we interact and behave in a particular space. So a storyline provides a certain taken for granted sequence of events that helps us sort of make sense of everything. So one example comes from Lengra-Suna's work, and she talks about in a project-based learning classroom how one storyline that she saw is the students start a project and it's sort of taken for granted that one student will take over, right? That one student takes the lead and starts facilitating the group. But students will willingly follow some students more than other students, right? So this is the taken for granted sequence of events, but based on who this student is, students will make sense of this action differently. Okay? So Lengra-Suna found that in the case that this student was a boy, everyone saw him as being smart for taking the lead. Whereas if the student was a girl, everyone saw her as being bossy for taking over. Right? So students were interpreting what was happening in the mathematics classroom group work based on the way that they're figuring gender, right, more broadly. So that what's powerful about figured worlds as a framework is it allows you to bring in influences from outside the immediate classroom to make sense of how students are interacting and engaging. So sort of as a summary, when I talk about storylines, I'm talking about this, again, taken for granted sequence of events that provide students some context for what counts as valued mathematics engagement and how students are making sense of themselves as successful or not, right, in relation to mathematics. And that then has consequences for how their mathematics identities are shaped. Right? And again, that can interact or that can intersect with students' gendered identities and how students are making sense of gender in the broader worlds that they live in. It can intersect with race or language or socioeconomic status. Right? So all of those different influences can come into how students are making sense of things in the classroom. Okay, so that's a little theory heavy. I read this book on this theory 5 times before I used it, so I'm happy to answer questions if you're having a little trouble making sense of that. But hopefully you have an idea of why this would be a way to sort of frame the interactions. So I'm going to shift now to talk about what I found when looking across these first 2 projects. So this is just sort of an overview and a snapshot of the way that students were participating across the different projects. So you can see here in project 1, students spent most of their time in whole class participation structures, right? So working together as a whole class. And a lot of that time was teacher exposition. So that's the teacher standing at the front of the board explaining how to do something while students are sitting at their own desk taking notes or trying to do it along with the teacher. Another large chunk of the time was spent on individual work, right? And so some of that was the nature of the project itself, right? They had to figure out if the distance from their individual house to a grocery store, right? So it was an individual project, right? But we see a lot of whole class and individual work across project 1. The shift from project 1 to project 2 is quite dramatic, particularly when we look at the increase in the amount of time that students spent in small groups. Okay. And then if we look at the amount of time that the teachers spent at the board, right, explaining how to do things, there's also a pretty drastic decrease there. So the way that students are engaging in mathematics is important because it creates different types of storylines, right, for what it means to do mathematics, what it means to engage and to learn mathematics. So we can see a little sort of snapshot of some of that difference with these numbers, and I'm going to talk a little bit more qualitatively about what was the nature of that difference. So in the first project, the main storyline that was really driving how students and the teacher were making sense of what it meant to do and learn mathematics was that the teacher guided the students procedurally, either as a class or individually, right? And we saw that was coming out here, right? Using the necessary mathematics. And so this is an excerpt from a moment of teacher exposition where Ms. Stone introduces a GeoGebra applet. So this is an app that's already been created that allows the students to sort of drag points around and try to understand the distance formula using the applet. Right? And so she wants them to sort of play around with it. This is the worksheet that they have here. Right? They're supposed to like look at these points and use the applet to kind of play around, right, and see what they notice about the distance formula. You can see here she gives them a definition for what the distance formula means more conceptually. So it's a way to measure the distance between 2 points in a coordinate plane. And then she gives them the formula directly, right? So they don't go through the process of deriving the formula, right, or discovering it on their own. And so she sends them off to work on this applet. And here she's trying to explain to them what they're going to do with it, right? So she says there's a GeoGebra applet and you're going to play with the distance formula. You're going to open up this applet and you're going to change the sliders to these points. Oops. So she means these points. And you're going to set up the distance formula. And so she shows how to do that on the applet. And then she says what the distance formula is. I've written the formula on the worksheet, but it's a fancy way of saying I need to know how far this, and she points to these 2 points on the coordinate plane, is on the coordinate plane. And so she shows how to set up the first problem on the worksheet in the applet, and then Jane says, I don't understand this, right? And so then all the students are like, we don't get this either, and so she ends up going through the whole worksheet with the whole class, right? And then the next day, students do more practice with the distance formula in a very procedural way. And so this is sort of an example of what it looked like in this way for the teacher to really guide the students more procedurally. So she's trying to make some connection to what the distance formula means, right? But for the most part, students are really just working with using the procedure. And so you can see that this is from the second day where they're working on using and practicing using the distance formula. There's quite a bit of struggle with using the square root in the calculators and things like that, right? So very procedural. So this sort of was very typical of the nature of mathematical engagement between teacher and students throughout Project 1. In Project 2, there was a pretty significant shift. So instead, students worked collaboratively with each other, but independently of the teacher, to figure out how to use and make sense of the necessary mathematics. So students were working through GeoGebra in this project as well, but they weren't given an applet. They had to construct their own centers of triangle. So this is from part of a worksheet that tells them how to actually construct centers of triangles in GeoGebra. And then it says here, drag the vertex of your triangle so that the triangle looks different. In other words, transform it into an acute, to a right, to obtuse, right? So they drag it around, and then they make different observations about what happens to the location of the point of concurrency. And so then they have to make some sort of generalization or prediction about what will always happen, right? What's always true of this particular point of concurrency. And so they did this for 4 different points of concurrency with triangles, and worked in pairs to do this. If students were struggling with how to use GeoGebra, the teacher had made YouTube videos showing and narrating how to do constructions in GeoGebra. So it was things like, how do I find a midpoint in GeoGebra? How do I drop a perpendicular line, right? So there were all these videos that students could look and watch and figure out how to make these constructions when they were struggling. So this is a group that worked together throughout Project 2. So here we have Rosie and Blake and Dante and George. So our 2 higher status students working together and our 2 lower status students working together along friendship groups as well. And so here is an excerpt from Dante and George working together. So Dante says to George, wait, go back to that thing, that video in GeoGebra. Ms. Stone said in the video, you have to click on perpendicular bisector. And then he points to something on George's computer in GeoGebra and says, click on that. So here you can see that they're going back and forth. So Dante has the YouTube videos up on his computer, and George has GeoGebra up on his computer, and they're working together to figure out how to go through the constructions and to make the different observations about each point of concurrency. So in relation to this storyline, there was another storyline that also came out in supporting this type of collaboration. And so in this particular project, the teacher also reinforced norms for small group tasks that required students to collaborate and required the participation of every group member. So I'm going to look at that in a little bit more detail. So here are 3 complex instruction strategies that Ms. Stone used in Project 2. So you can read a little bit more about those complex instruction strategies in some of the research that's been written about that. I'm going to talk today about group questions and participation quizzes. So group questions are the idea that you're not allowed to call the teacher over to ask a question unless everyone in your group has the same question. Right? And that's supposed to encourage collaboration because students have to ask each other if someone in the group knows the answer before they ask the teacher. Right? So it's supposed to encourage them to rely on each other. And so even though students were working in pairs, they were technically supposed to be a group of 4. Right? So here in this excerpt, you can see Rosie has a question, and so she asks everyone, do you guys all have the same question of what is the point of concurrency and where to put it? And Dante doesn't really look up from his computer, and he says, yeah, and then Rosie raises her hand, they call the teacher over. Right, so sort of artificial, right, playing along with this particular norm, but this sort of beginning to reinforce, right, that you at least ask other people first. With the participation quiz, we see a little bit more genuine engagement with some of these complex instruction strategies. So participation quiz is a quiz in which students receive a grade on how they participate, not on the accuracy of the mathematical work that they do. Right? And so for this particular participation quiz, students were evaluated as a whole group, because you get a group grade, right? You don't get individual grades. So the group was given a grade based on their ability to get started quickly, to provide justification of how they sorted the cards, to ask their group mates why they sorted the cards in a particular way, and to make the materials accessible to everyone in the group. Okay, so there you can see the focus is really on getting all 4 group members to participate. So the group of 4 had a set of cards that they had to sort, right, based on the type of segment, and then they sorted a visual representation of each segment, the definition, the name of the point of concurrency, when you put 3 of those segments in a triangle, and any special characteristics. Right? So they had all the cards sort of randomly spread out on the table, and they had to sort those correctly. So this was done after the GeoGebra exploration as sort of a review and a checkpoint for the teacher to make sure that all the students had taken away from the exploration the intended mathematical ideas. So with the participation quiz here, you can see initially Rosie had all the materials, and then Blake reminds her that they're being graded on having all the materials accessible to everyone, right? And so she pushes them to the middle of the table, and Dante and George ask what they can do to help, and so they help cut things out, and then eventually they start sorting, right? And you can see much more collaboration across all 4 of them. And so this is an excerpt of what some of that collaboration looked like. So here you can see Rosie says a visual picture of an altitude. She does a search for altitude on her phone, and Blake says, good job on using your technology, very loudly so the teacher can hear him. Right? And then Rosie shows her phone to the other group, mostly to George and Dante, and says, okay, so look for something that looks like this. And they look at the cards with the diagrams on them, and Rosie says they all look the same. And George actually is the one who says not all of them. This one has a right angle. Okay? And then there's some intervening discussion about which one has the altitude, and then finally Dante says here, right, and he hands her a visual representation of median. He says the median is the point in the middle. She says, oh yeah, smart. And then she says, are you sure? Okay? Because this is coming from a student who's typically not seen as being smart, right, in mathematics. So you can see here that this reinforcement of particular norms about what it means to collaborate gave George and Dante access to participating and engaging in mathematics. So just a quick sort of wrap up of some of these points. So from Project 1 to Project 2, in Project 1 we see what would be typical of most secondary math classrooms, where only some students are good at math and the teacher has most of the mathematical power, to a classroom in which everyone can be good at math, right? Beginning to see that in some of those interactions, and there's more mathematical power with the students. So, not sure why my slide stopped advancing. There we go. Okay. So in the first project, we can really think about the teacher balancing some of the challenges of bringing in critical mathematical inquiry by doing more teaching by telling, right? So it could be the challenge of the social justice project, it could be the challenge of using technology, right? So there's a lot of complexity going on there, and she's really managing that by just telling the students what to do mathematically. Right? Whereas in the second project, we see this shift of balancing some of that challenge through using intentional strategies from complex instruction. What's important to note is that status differences still persist, right? So Rosie is still the smart one, right? And Dante and George are still not the smart ones, right? So we still see that persistence with status differences, but we see more opportunity, right, for George and Dante to have to be able to enact identities as people who can do and learn mathematics. And so this shift towards more equitable learning and more equitable teaching is a complex process, right? It's a gradual process that takes time. And so we shouldn't expect that, even though we saw these differences, right, that everything will be more equitable just because we introduce complex instruction strategies. In other places, so in other papers that I've written, I've talked about how these shifts in the mathematical engagement also parallel shifts in the way students engaged with the social justice issue. Right? So as students engaged in more inquiry with the mathematics, they were also engaging more willingly with inquiry with the social justice issues as well. So that's not a part of this particular paper in detail, right, but I go into that in detail in other places. So some things to think about with this is, again, reiterating this idea that identities are fluid. So being able to see how some of these different storylines come up within the same classroom within a fairly short amount of time. Right? So when we think about change, we often think about these big changes, right, to teaching instruction, but often creating more space for inclusion in mathematics can be a more gradual and subtle process. And along those lines, a lot of the work we have on complex instruction is with master teachers who are quite skilled and use complex instruction consistently and all the time, right? And here we see more of an emerging complex instruction practice that still has benefits for how students engage. And then finally, this combination of pretty sophisticated and challenging teaching practices seems to help manage some of the tensions that come up in one. Right? So we might think that newer teachers aren't able to handle these complicated teaching practices, but actually drawing on smaller strategies from different practices to support certain goals can be quite effective. So in relation to what I learned from this particular study, I wanted to just mention a third line that my research is beginning to take is thinking about how various stakeholders can support equity-minded math teaching efforts. And so for me, that has been thinking more about families. In my role at UT, I've been more involved in family STEM nights and thinking about STEM in community settings and with community members. And then I'm also starting to think about more of the top-down approach. So in the way that we evaluate teachers, is there an opportunity to support more equity-minded teaching? So thinking about sort of both directions that are also influencing what's happening in the classroom. So that's just a little bit about sort of where I'm headed. So if you're interested in either of those, I'd be happy to talk with you. Now we have some time for questions.